Welcome to this video lecture of statistical quality control of concrete in mixed design. Actually, before starting the video lecture, it is more important that we will understand that what is design mix or mixed design. Mixed design can be defined as the process of selecting suitable ingredients of concrete and determining their relative proportions with the object of producing concrete of certain minimum strength and durability as economically as possible. Actually, the relationship between aggregate and the hydrated cement paste, which are two essential ingredients of the concrete. Now, in this workability of the mass is provided by the lubricating effect of the paste and is influenced by the amount and dilution of the paste. Now, the second main important thing is strength. The strength of concrete is limited by the strength of the paste. Since material that is mineral aggregate with rare exceptions are far stronger than the paste compound. That is why it is more important to check the paste. Essentially, the permeability of concrete is governed by the quality and continuity of the paste. Since little water flows through aggregate either under pressure or by capillarity. Since the properties of concrete are governed to a considerable extent by the quality of paste, it is helpful to consider more closely the structure of the paste. With the given material, the four variable factors to be considered in connection with specifying a concrete mix are: first one is water cement ratio, the second one is cement content, or you can say cement aggregate ratio, the third one is gradation of the aggregates, and the fourth one is consistency. Now, concrete mix design is a step-to-step procedure to work out various proportion of the ingredients which got to make the concrete. Now, there are various methods of mix design available. We will discuss afterward about the methods. Now, it is difficult to design concrete mix in our country as the materials available from time to time are not at all consistent in the quality. Now, if we discuss about the various methods of misproportioning, it is arbitrary proportion, IRC 45 method, high strength concrete mix design based on flexural strength, road note number 4, that is grading curve method, ACI committee 211 method, now DOE method, or you can say mix design for pumpable concrete method, Indian Standard Recommended Method, that is IS 20262 2019, volumetric method, fineness modulus method, maximum density method, surface area method. So, out of all these methods, we have to decide certain methods. Now, what the video lecture is about is statistical quality control of the concrete. Actually, many factors influence the strength and quality of the concrete. This results in variation of strength from batch to batch and within the batch also. It becomes very difficult to accurately assess and predict the strength of the final product. It will be very costly to having very rigid criteria to reject the concrete in structure on a basis of single or very few standard samples. The basis of acceptance of sample is that a reasonable control of concrete work can be provided by ensuring that the probability of test result falling below the design strength is not more than a specified tolerance level. Actually, the aim of quality control is to limit the variability as much as practicable. The statistical quality control method provides a scientific approach to the concrete designer to understand the realistic variability of the material so as to lay down a specification with proper tolerance to cater for unavoidable variations. To maintain the quality, certain statistical tools are available, such as mean strength. Actually, mean strength is the average strength obtained by dividing the sum of strength of all the cubes by the number of cubes. That is, x bar is equal to summation of x by n, where x bar is equal to mean strength, summation of x is a sum of the strength of each cubes, n is equal to number of cubes. The second thing is coefficient of variation. Actually, it is non-dimensional measure of the variation. This method is alternatively used for variation. Now, coefficient of variation, that is nu, is equal to sigma by x into 100. That is, it is the ratio between standard deviation to the mean strength into 100%. By this, we can find out the coefficient of variation. Now, third is variance. This is the measure of variability or difference between any single observed data from the mean strength. That is, variance is equal to x minus x bar. The next one is standard deviation. It is the root mean square deviation of all the result. Generally, it is denoted by S or by sigma. That is, sigma is equal to summation square root of summation of x minus x bar whole square divided by n minus 1, where sigma is equal to standard deviation, n is equal to number of cubes, x is equal to particular value of observation, and x bar is equal to arithmetic mean, or you can say mean strength. Now, just take one example to understand all these formulas. Now, suppose that you have taken 20 cubes. Now, these 20 cubes are having sample number 1, 2, 3, 4, 5, 6 up to 20. And according to this number of cubes, there is a crushing strength, or you can say compressive strength, which can be denoted as X in megapascal. Now, the crushing strength value is given, that is for cube number 1, the crushing strength value is 43, for cube number 2, it is 48, and so on. Now, if we add all these strength, the crushing strength, that is 43 plus 48 plus 40 plus 38 plus 36 and so on up to 28th cube, it will come as 804. It means that summation of x is equal to 804. Now we are finding the average strength, that is x bar is equal to summation of x by n. The value of summation of x is 804. It means that 804 divided by 20 is equal to 40.2. Now the value of x bar is 40.2. Now in the fourth column I am finding the deviation, that is x minus x bar. Now for example, the first cube x is 43. Now 43 minus 40.2 is equal to plus 2.8. The second cube value is 48. 48 minus 40.2 is plus 7.8. Now the third cube value is 40. Now 40 minus 40.2 is equal to minus 0.2. Now in this way, I had already calculated the deviation, that is x minus x bar. Now in the last column, I am finding the square of the deviation, that is the square of this column value. For example, plus 2.8 whole square is equal to 7.84. Plus 7.8 whole square is equal to 60.84. Now, in this last column, I had calculated the square of the deviation formula value. Now, in the last place, you can see that sigma, that is standard deviation, is equal to square root of summation x minus x bar whole square divided by n minus 1. It means that we have to sum up the value of square of the deviation. Now, if you add 7.84 plus 60.84 plus 0.04 plus 4.84 and so on, so we got the value 359.20. It means that sigma is equal to square root of 359.2 divided by 20 minus 1. That is, sigma is equal to square root of 359.2 divided by 19. The value comes as 4.34 megapascal. Now, if you have to calculate coefficient of variation, then the coefficient of variation is equal to standard deviation divided by average strength. That is 4.34 divided by 40.20 into 100, it will come as 10.80%. Now you can see that standard deviation and coefficient of variation has to be used to determine average design strength of the mix. If you have used standard deviation method. In that condition, S average is equal to S minimum plus K into sigma, where S average is equal to average design strength, S minimum is equal to minimum strength, or you can say the target minimum strength, and sigma is equal to standard deviation, and K is equal to probability factor or Himsworth constant, which can be taken from the IS mixed design table or ACI table. If you have used, instead of variance, if you are using coefficient of variation, in this condition S average is equal to S minimum divided by 1 minus K nu by 100. Now the nu is equal to coefficient of variation, since in this method we have used the coefficient of variation, and in this method we had used variance to calculate the average minimum strength. Now we have to note it down that when we have to use coefficient of variation and when we have to use variance. Actually, coefficient of variation is mostly used. It has been proved by research also that when relatively low strength has to be calculated, in that condition we use coefficient of variation, whereas standard deviation is used at high strength. Now these are certain statistical tools which we had used to control the quality of the concrete. Thank you.